Okay, hello there. I started working on this this old Westinghouse portable DC welder. Been sitting for about 30 years in the back of a pickup, and of course it was seized, and managed to get it freed up here. Brushes and everything looked okay. That's kind of why I pursued. But going online, I found it very, very difficult to find any information on it. There was one fella who I just actually Googled the image because I couldn't really, all the numbers on here don't seem to jive with anything. And it's coming back as a World War II generator, and they keep referring to aircraft generator, and I'm not sure why, which really has no relevance, I guess. The point is, there isn't a lot of information, so I decided I better throw something on here just in case there's anyone else in my shape. Trying to find wiring schematics and things like that, and it's virtually impossible unless I just haven't tried hard enough. However it is, applying the little bit I do know about motors, motors / generators, I guess. It's easy to tell that the brushes have to be excited here, and it's a variable excitement. The wires, when I took them off, had all been cut and twisted, and so Lord knows whether it was the right way to wire it or not, and I have soon discovered that it wasn't wired properly. It looked like they were trying to rob the residual power from the stator to feed the actual rheostat system, which variably drives the voltage to the brushes. Now, I sometimes get confused when you throw in brushes and stuff. I do a lot of work with PMAs, generators with magnets in them. And of course this is electromagnet, but it is a DC generator. So what I've done, I've got it clamped to the table here, but I did come up with a way of bench testing this thing. There's no sense building this and mounting it to my tractor. I actually have a small utility tractor I want to mount this to. There's not a lot of sense doing that if this thing is scrap iron. Since the condition of the brushes are good, like I say, I'm going to pursue, but I wanted to just maybe pass on some stuff here. I'm going to bring you around to this side here. It's clamped down, otherwise I'd just turn it. But just excuse me here for a minute. So we've got our main connections coming in there, and the way it was wired is your stinger on one side and your ground lead on the other, which is simple enough. I couldn't seem to figure out why they had a wire running up with the stinger that almost looked like you triggered it. Irrelevant, I guess. So here's kind of the basic wiring. Would be sorry, I say a lot. This would be the rheostat, the variable rheostat, and you can see I've actually had to patch it here and here because the leads broke. So I had a couple of dead ones here, so I just soldered across. Kind of tricky to do, but where would you find something like this day and age? This is ceramic, so it's very delicate, but I do have it working now. And with that patch job, we bring the variable power through the resistor. So basically from the battery up into the terminal here, and then it gets distributed through this brush as it goes around. It even has an off position. And as you dial up, the resistance decreases, increasing the voltage. So we've brought power in from the battery here, and it's just a little 12-volt battery, and it's coming out here variably through this filament wire, or what would you call that, element almost. I imagine that would get quite hot. It's using this as a heat sink, the ceramic board, and then basically it just comes into this terminal here. Now I don't know if it matters which terminal that it comes into, but originally when I undid the wiring, that's where it came in. So they actually had that rheostat across the bottom small terminal and the top small terminal. Keeping in mind the welder's actually standing on end, it would actually lay down. So we bring variable power into here, and then we just hook this side here up to the ground of the battery, and that gives us variable power to our brushes. With that, I'm just using the old DeWalt here to just to variably drive to mimic basically the drive system. So as I dial that rheostat up with the drill on, my voltage and my amperage are variable here. So I just wanted to pass this on. There's not a hell of a lot out there. Now I don't have this mounted yet, so my results could be not what I'm expecting. It's coming up as a Westinghouse 200 amp DC generator, I believe. But it seems to be common that they were used as a welder, and that's how this one was mounted. Big belt drive sort of deal. So I just wanted to make a note of that and maybe get some information out there, because it does seem very, very difficult to find. So if anyone has any information on any of these that I might find helpful, I'd be happy to read any comments or whatever you might have. Thanks. Okay, back to our welder project here. It is very difficult to find anything out about these online. There is one fella who did build a welder out of his, a portable welder. The last I had read on his blog there, which I didn't spend a lot of time on, I'm in working mode, not in reading mode, is that he still couldn't get it to weld. Now I don't know if I got mixed up and I got into some older blogs or whatever it might be, or whether that problem's rectified. But here's what I've come up with. Some bench testing in the shop proved quite quickly that the rheostat had completely failed. And I'll see if I can get you a shot of this here. Simply hooking an ohm meter up to here, it doesn't take long to find your faults. And I found one here where there was a broken continuity, and obviously this one here, which was visible. So I had focused on this one here just by running a little jumper lead, and then I had resistance all the way till I got here, and then I had nothing. However, if I move the brush over here, I'll say right there, and I go back to this terminal, I had fluent resistance throughout here. Therefore, isolating the break was quite easy, and fixing it, of course, not so much. Very difficult to solder. I ended up just soldering some copper across 3 terminals that were bad. So I had power here and power here, nothing here, so I straddled it. Obviously an age thing, probably expansion, contraction, poor connection, whatever it might be. You'll notice that the wires, I'm drawing a blank on the name of the wire, I should know it. It has resistance in it, and obviously the more footage you have, the more resistance you'd gain. It changes sizes. There's 3 different sizes in here. Down here it's quite small, and then it gets to a medium size, and then it switches. So it's probably where they joined it that's failed. But however, that little bit isn't going to make, it's going to be a bit of an amp difference. Being this is on a PTO drive or a belt drive, that can always be adjusted by adjusting the speed as well. So that's kind of a bit of a patch job, but I'm not even going to attempt to find one of these. In fact, I had to get a little bit destructive. I had to break the knob off of this. It would not release, so I had to put it in the vise and crush it. Quite durable, mind you, but that's sometimes the way it's got to be. So with that, I've discovered the wiring sequence to this is simply run the power through the rheostat, so power in through here, comes out through this brush. Brush obviously touches wherever you set it, and it variably adjusts the voltage, which comes out of this terminal here around this filament. I believe that's a filament. It's more of a resistor, I guess. Obviously getting hot, hooked to this ceramic board. And then it goes out, and it goes out to the one small terminal where your main leads come in for your stinger and your ground. It goes through the stator, variably voltage with this, and then the other terminal just hooks to ground. So I just tested it here with a small battery. Dial this up, dial it down with the drill going. Got to be careful, it's clamped down. You spike that, you'll spin this right off the table, sort of thing. You gotta, or you'll break your wrist. You'll break your wrist on the drill there, just with the amount of torque. Just with the amount of torque you'll get. And of course, increasing voltage becomes very difficult to turn. So that's kind of where we're at for now with this project. It's looking very, very positive. Brushes, like I say, brushes got the bearings seem to be nice and working quite freely. Haven't worked a lot with freeing this guy here up. It is free, but it's a little sticky. We are going to get to a reassembly point here, and then the next question is how I'm going to drive this and with what means. I have so many options, and I'm leaning towards multi-option. I'll get to that maybe a little later. Hopefully we can get this old girl to weld. Okay, just putting this, this would be, I guess we could call it like a shear system, where if you over torqued it, it would break free the drive system from the welder. I went and cut these little retaining wires just because they were all twisted to hell, and it would have taken me a half a day to get them out of there. The wire's quite small. There's little holes through each head of these little retaining screws. I'm just going to use an old piece of MIG wire. If there's any, I didn't really show much of the assembly of this, but it's fairly straightforward. It's really not that complicated for anyone who has any sort of mechanical experience, but just wanted to point out that maybe a guy should have saved those wires, taken the time. It's very small wire, but MIG wire seems to work. So I'll get that all wrapped up, and then we're going to mount the two of them back together. A little bit of anti-seize inside here where the splines ride. Got a piece of MIG wire as a retainer wire. Just going to slide this back together here. Gave the bearings in here a little bit of a shot. I think it's just from them sitting for so long. Slide that together in and out, get some of that anti-seize on the shaft there. And I'm going to find some new bolts here for this, and we'll get that coupled up, and we'll maybe start reassembling. We're going to maybe get it into a testing stage before we get fancy and start painting crap. I'm not much for painting stuff, but something like this here might deserve a chance to look new again. So Okay, I just plugged it in. It's obviously laboring this poor little quarter horse way too much. I'd seen something I'd never really seen before. It'd speed up and slow down, speed up and slow down, almost like it was cutting the breaker, but it actually didn't cut the breaker. So it may have been overloading the motor, and there's a protection in there or something. I don't know if this has that centrifugal clutch in it that has a starter in it, and then it actually kicks into high gear. Maybe that was kicking in and out. And this poor little attempt for a cord I have on here was getting so warm I could hardly hold it anymore. So that's a pretty good indication to me that, being this came off the old tractor, this thing's probably only spinning at 500 to 1,000. So I'm just gonna plop about a 3-inch on here. This is about a 4-inch, so we're actually gonna, if this is 1,700, we'll be looking at about 1,000 or not even, 1,200, somewhere there. We'll give that a shot, see if it sounds any better. All right, here goes. Maybe I'll throw on some welding gloves here. I got tagged yesterday a little bit when I broke contact, which doesn't really mean a lot. I was touching the battery post and the stinger at the same time, and I think when I broke contact, just gave me a little tag, which I know there's a reason for that, and it's nothing serious. It's not even that uncommon, I don't think. So we've got just our 12-volt source for now through the variable rheostat that comes up into the brushes, we'll call it the oh darn, I should know the name of that. It's not the exciter, it's the shunt, the shunt coil. Out of the shunt coil back to ground and back to the battery. So I'll hook this up here. I'm going to make sure that this is off to start with. And what I'll do is I'll just run the motor and I'll just turn this on and see if it changes the load, and then if it does, I'll try welding at a very low amperage, which is probably going to stall out the motor anyway. But if I can get an arc off of here, I know we're barking up the right tree here. So hopefully this isn't the demise of this poor little thing. So we'll start her up. Well, as I adjust the voltage, of course, the amperage draw on here changes as high as 3.5 amps. The amperage draw on this when I was striking actually peaked at 13.5, but it averaged about 9.5 to 10 amps. So the first thing that I'd like to rectify, knowing that this welder is going to weld, or in theory it's going to weld, is I need to get this up to 24 volts. So I'm going to set up a 24 volt battery bank, and from there we'll see how that affects the arc. If I can get some, if I can pull about 30 or 40 amps, I should be able to install that little black motor, that little electric washing machine motor. The reason I want to pursue a little bit more testing here is because I'm going to get a 15 horse motor to run this, and when I get the motor I also want to get the right pulleys, so I kind of need to know where this thing needs to spin at. So assuming those old tractors run at 600 or 700 RPM, we could assume that there was like a 4-to-1 gear induction on it, and if that's the case, I believe a 15 horse, a typical horizontal crank, would probably run around that 3600 wide open. So do we go with a 1-to-1, or do we go with a gear reduction, or what do we do? So right now I believe we're at 1750 on this little guy. I don't see any reason why it wouldn't be 1750. So we're running this at, let's say, 12 or 13, maybe even 1500. So we just want to test it just a little bit more, but we're turning our 3.5 amps when this is wide open into 13 amps. So it's definitely working to a degree. Whether it's enough to weld or not, I could stab it with a rod and poof, it's over, right? So I've heard of that happening where they just can't handle the load they once could. So we'll keep tinkering here. Okay, we're at 24 volts. I had to rig up a shitty combination there. I know you're not supposed to hook two unequal, unlike batteries together, but all my other batteries seem to be needing a charge, so here we go. Alrighty, 20 amps on the Stinger, full out, 5 amps on the battery. So, obviously, one of the first things would be this wiring here is not letting the current through that we need. It's not warm by any means, it's only 5 amps. This is nice and warm now, and I've heard stories that'll glow red. So now what it's coming down to, I had that motor working good. So it seems like what it's coming down to now would simply be the speed this thing is turning, I guess. So, oh, there's that some number plate on the back here. I'll find out what that motor's spinning at, and then we'll be able to better judge what we got going on here. $17.25. So we're going to maybe have to get this turning just a little bit faster, which in the application we're going to put on this with a variable engine, a 15 horse, we will soon be able to adjust that quite nicely, assuming that 15 horse hits the 3600 like a typical 5 or 6 horse does. So I'll maybe see if I have a different pulley. We'll bump that up 1 notch maybe, and we'll see if that helps us out at all, if we can create any more amperage by increasing the speed. Okay, poor man's way. Got a nice big ground cable here going directly to the battery bank, and then I just run double leads to the oh boy, variable rheostat, and then double leads to the shunt. So we're getting about 8 amps there, which I don't know if it's a big increase, but we'll give her a shot here and see where we end up here. I go looking for my gloves again. That was easier. We'll plug her in and see what we get this time. Wow, we got a much easier 40 amps that time. Nothing really over, except for the initial one, where I have the welder wide open and then I do the initial strike. A poor little 3rd horse motor there is just, wow, you can really smell it in here. She warmed up real quick. And the belt's a little bit warm, indicating a bit of slippage. So it becomes apparent real fast that the 40 amps is, well, we all know what it's like to try and weld with 40 amps. It's just not enough. And then of course as soon as I strike, the little motor takes such a hit. But I think it's safe to say that this old girl is in welding condition. So with some new cables and stuff, and that's my next thing here, is some of these cables are just beyond anything you'd ever try and weld with. And I don't see the point in putting new cables on a welder that doesn't weld, but I do have some And I think now's the time that if I were to switch that out, I'll bet my amperage draw would easily increase simply because of you know, better connections and stuff. I got it horseshitted here. I didn't want to solder on a big end on there for no reason. So, but at the end of the day, I believe we're sitting pretty. We were drawing 7.2. It actually went down when I started. I had 8 amps going through. So obviously the resistance would increase a little bit when you start it and run it. So if we base everything on 8 amps, this project's going to take off a little bit here in a different direction. But in order to justify the direction I want it to go, I have to be sure, and I believe I'm very comfortable now knowing that this thing here is going to weld. So I'll maybe leave this welder as is for now. I'll maybe close up this video, and if there's any problems I have with it, of course I guess I'd add it on. But at this point, I think I'm going to go forth with the project, and it's a combination project. It's going to be a gas-powered air compressor / welder. Now, it's still in the making, but I do have all the major components I'm going to need. And because I was already building the welder, or sorry, the air compressor, all I needed was about a 6-horse engine. But when this came along, I thought, well, I can kill 2 birds with 1 stone, and I can put a 15-horse engine on with electric start and have a completely portable 24-volt welder and a portable air compressor as well. So I'll end this video here, and if there's any questions or comments, or if anyone's having similar trouble, I'd be more than happy to show the little bit of knowledge I do have on it. I'm going to assume that this thing welds, and as long as it does, maybe if I could get some welding footage with it, I would maybe attach that to this video as well. So there you have it.